All right, let's get rolling here. Okay, so, well, you know what? First of all, to start off, I hate it when people start off things by saying, oh, hey, raise your hands if this or that, but I actually am really curious. How many people, have used or messed with Kubernetes at all at this point? Okay, it's like a half a year old or something, or it's pretty, so it's, but just curious about that. I won't ask any more audience participation, hand-raising questions. All right, so my name is Jason Brooks. I work for Red Hat in the open source and standards department that, there's a bunch of the other speakers in this room, same team as them. And we are focused on, the open source projects that Red Hat depends on. And so Brian earlier said it well. I mean, it's kind of fun to kind of be in a part where we're really not even thinking about the product necessarily. We're just sort of working on the idea that, hey, if the projects do well and people learn about them and get to use them, then we will, others will figure out how we'll make money from that. So I don't know, it's a fun part of the company to work in. And before that, I spent 12 years as a tech journalist. I worked for eWeek, and I wrote product reviews of all sorts of different products and stuff. So some of the stuff that I do, now at Red Hat kind of involves, I imagine, okay, I heard about this product, I heard about this project back from my writing days, try it out, and just sort of, you want people to have a good experience or just to actually do something real with these cool new projects that's kind of, beyond your hello world. And so that's some of what I kind of bring to stuff. And this is like, right, the new hotness, it's all about containers, and that's, everybody's got to, be in a fever pitch to containerize everything. And so I'm like, all right, let's check it out. Let's do some stuff with this. So, the basic stack here, right, this is funny to me is that Docker's like a year old, and it's the most mature of these three things, at this point. I mean, the Atomic Host has they all have a lot of old stuff in them, but I mean, as, entities, that's funny. I think it was like last year that I was hearing about Docker at scale maybe, and or maybe it was the year before that I was just hearing about it, and it's crazy how fast it's gone. But, the basic story, I think, most of you probably heard about Docker, but it's just basically you take your app and you make it shipping it around easier by putting it into a container, like a container ship type of thing. The Atomic Host, it's sort of it's an optimized host for running these containers. You've got or maybe not people in this room, maybe you guys are all on Linux on your desktops, but maybe you have your Mac and you've got boot to Docker and you're working on an app. But at some point, you're not going to deploy that app, to a MacBook in a data center somewhere with boot to Docker running on it. I mean, at some point, you're going to have to find like a sturdy ship to put your container onto, and that's what the Atomic Hosts are aiming to be. And then Kubernetes. All right, we got to load up these containers. We got to load them up and get them on their ships and move them out. And if one of those ships sinks, somebody's got to be paying attention to that and send out hopefully a replacement container. So Kubernetes is serving that role, and this is really what I was focused on. Is that okay? We've got Docker, that's easy enough. In the Atomic Host, it's pretty clear. It's a lot of new technology in there, but it's just a Linux server. But Kubernetes is, it is definitely the rawest of the three, the newest of the three, and this is just kind of an exploration that, starts with, okay, well, you got to start off with, you got to build your Kubernetes cluster. So Docker's like, ultra easy, just install it and you're off and running. Kubernetes, you've got to get a few VMs or machines or something together that you're going to be orchestrating, right? Your little fleet, and it's pretty easy to get one up and running. You can the Kubernetes site and the Kubernetes GitHub repository has like a ton of examples of how to set up a cluster on are you an OpenStack person? Are you you're doing your Vagrant? Are you, CentOS, Fedora, Ubuntu, every core OS is, every sort of vessel that you might want to put your, build a Kubernetes cluster out of. There's pretty there's instructions for all of them. The easiest that I found is Google Compute Engine, and Kubernetes is a project started by Google. That's just Google's. It's running on their VMs in their cloud, and they just sort of automate setting it up. And there's a few like goodies that are in Google Compute Engine that are a little trickier otherwise. So you're definitely getting the feel. Okay, this is something that has been put together from a Google perspective, but it's not that those can't be implemented for your system of choice. But that's if you kind of want to just get rolling and are finding the various how-tos to be a little more time-consuming than you might want. That's like a real fast way to just start playing with it. You're paying by the hour, but whatever. So first off, basically you can do the ultra boring Kubernetes example. It's just basically a little file that's saying, hey, run this container on one of the machines in my cluster. So that's good for your little how-to about setting up Kubernetes. The next thing is they have a pretty nice guestbook app that's sort of like the canonical Kubernetes app that sort of exercises all the parts, and that I definitely recommend. And there's, again, most of the how-tos just for your different platforms sort of flow into running the guestbook app, and that's a good way to kind of get your feet wet. But after having done those things, I wanted to do a real app of some sort, something that I have some kind of realistic requirements around. And GitLab is something that we run internally. I actually run it. It's one of those things where, hey, I wish we had a friendlier Git repository for our little team internally to use. And then it's 2 years later, and there's just a ton of repositories, and I'm running it in a Fedora VM in my lab equipment, and somewhat, bit worrying at night that it's going to go down, and at least everyone should have their Git repos also on a local machine somewhere. But it's just one of those things. So this is sort of an app that's both sort of a testing app, but it also has real requirements, and so it's more of a real world kind of case study for me to get my feet wet with it. So GitLab is basically a Ruby on Rails app, and it needs a Redis store, and it needs Postgres is what I use, but you can use MySQL also with it. And this is a thing that the guestbook app is also a multi-container app, and this is part of the point of Kubernetes. You've got these various pieces to your application, and it needs to be orchestrated. So it was a good thing to try out for that. So Postgres, Redis, and then kind of the wad of or the stuff. I'll talk about that a little bit later. The GitLab bits is kind of a third container. This is kind of how I approach this. Now for Postgres and Redis, it is ultra easy. There's this CentOS Docker files repo. It's the CentOS project maintains it, and there's one exactly like this for Fedora. And there's just a ton of different applications, and it's pretty much they're all things that there are already packages for CentOS, and then community members have gone through and they have made Docker files out of them. So the first step was grabbing this kind of off-the-shelf Postgres and Redis from the project, and so that part again easy. For the GitLab part, I'm interested to see as containers continue to take off, the ISVs starting to actually deliver their products in containers. I'm not seeing so much of that yet, but that's going to be a real kind of proof point in my mind is when you really start to this great delivery mechanism, which I do think is great, but when it actually starts to be is being used for vendors to deliver their applications, and maybe some people are doing it already. But for instance, GitLab, they don't do it that way. They offer this what they call an omnibus installation, where everything's smushed together in one container. And but there's a community member who had put together a Dockerized GitLab, and that person, I'm not sure, but he or she did it in Ubuntu. Now, one cool thing about Docker is that on a certain level it kind of doesn't, well, it can not matter on a certain level what OS is actually in your container image. But, it really does matter. I mean, when you get to where you're starting to debug things, or, okay, this little, especially when you're taking your container that might run, as expected when you're running it on your laptop or on your server or whatever, just in plain Docker. Then when you start to move it over to something like Kubernetes where it's orchestrating it, it's important to understand, have a decent understanding of what's happening in the OS in your image to figure out what's going wrong when things go wrong. So I converted it to CentOS. It was basically just, converting Debianisms to RPMisms, -dev packages to -devel and things like that. It was actually pretty easy. The gnarly bash scripts, I mean, it uses a lot of bash scripts to do all this initialization. That's my Docker file. But it's just like this big old, big old bash script, and this is like one of the bash scripts. And so this is kind of what I was going through and having to say, okay, well, that's not the way it's done in CentOS, and I'm getting an error there. Also, the bash script that the community member had made, it gives you the option of either having Postgres or Redis rolled in or having them separate, and it's trying to detect for that, and it's trying to do clever things like, oh, I can run Docker within Docker if I need to, and it's just stuff that I am using this, but I have gotten interested. Some of the cool Kubernetes how-tos that I mentioned use Ansible to put it roll out the cluster, and I've started to get more interested in Ansible, and I am interested in using that as a way to kind of simplify some of the stuff that has to be done and make it easier to trace. That's kind of for the future comments portion of it, but it was actually pretty straightforward to do that, to convert it to CentOS. So then I've got my containers, and I run them directly. You can run them directly in Docker, and I just run my Redis and run my Postgres and run my GitLab directory and pass environment variables. When I run them to make it work together so that the GitLab container knows how to talk to the DB and whatnot. So once I had the containers, then it's time to write the definition files that Kubernetes uses, and those can be made in JSON or YAML. I did JSON just because that was the examples that I was starting from, but I think that I might switch to YAML moving forward because it seems a little more readable to me. But here's, for instance, this is the Redis pod. So actually, wait, I'll just talk a little bit. So the pods, right? The pod is like, it binds a container or a group of containers to a particular host. And so it's like it's like actually my own GitLab thing and my Fedora VM where everything's running on the same VM. It's kind of like that model. Everything that's in a pod together is kind of like as if it was running together on a machine. And then and they're not meant to stick around. So you could have your pod could be on one machine, and then it could be killed later and show up on another machine, and that's okay because services give Kubernetes a way to you can always count on the services. The services will continue to be there, and they will know how to connect to the pods. And so the services. So I'll just show. This is what the pods look like, and it's pretty straightforward. It can be pretty straightforward. The Redis one is just this is what the port I want on the container side, the port I want on the host side. They're just the same, and then this is my image. That image is Jason Brooks Redis, but that's just a straight up copy. I built it out of a CentOS Docker file that I showed you guys. They can be a little more. This is a service for Redis. The Redis service file, it's pretty simple. But you can do other things like the Postgres one. You put your environment variables in there. And then I think the GitLab one, also this is how I'm telling the GitLab one what the environment variables are from the, and then also I'm defining more ports for the GitLab part. than for the Postgres or Redis parts. That's what those look like. And now, let me see, I'm going to start up. So, let's see. Let me just see if I can, I'm just going to skip over here. So, yeah. This is how I'm pointing. This is on my local system, and I'm going to start up Redis first. Now, one thing is the order that you launch the containers and the services and stuff matters, because I need the GitLab container or pod to know about the certain environment variables from the Postgres in particular pod. And the only way it can know about that at this point is if it is launched after the Postgres pod. And this is something that I tore out a lot of hair, getting this down. So there's the Redis pod. I'm going to start the Redis service. Yeah, so Kubernetes is moving fast. And it might already be implemented. I know that just as little as a few weeks ago, I was reading discussions about an additional definition that basically would sort of orchestrate these separate definitions. But, I mean, a lot has been changing. Syntax has been changing. This kube control command was kube config like 3 months ago or 4 months ago, and it's been moving pretty quickly. But that is something that, I mean, it's sort of been, as I've understood it, it's something that is coming, is being done, and it's just a fast-moving situation. All right, so I need to get those up. So, and then replication controllers. So, the guestbook example has a good example of this. I'm not using a replication controller in mind right now, although, because at the time I thought, I'm going to figure out a Postgres replication. I'm going to figure out exactly how this needs to work in GitLab. Because again, going back to the way that my app is deployed, it's just that single VM. So I haven't sort of taken on these things. But actually, even for a single VM, if there's only going to be one instance of a container or a pod, it would still be good to have a replication controller, because if it gets killed, it can just restart that. Again, the pods are, when they're created, they are bound to a particular host. So if that host goes down, then it would be the replication controller that, even if you only have one, that would be starting it up on another one. But I put this in here for completeness, but my example right now doesn't include this. So yeah, and I mentioned the startup order matters with the environment variables. And let me actually start up my GitLab one too, because that takes a bit of time. Because what GitLab does is, once it starts up, it does a whole bundle operation, and yeah, all right. All right, so startup order matters. Another thing, this is one of the things I mentioned, that there were some kind of little Googleisms where things are a little nicer if you're using the Google Compute engine. And one of those things is this create external load balancer item that you would put into your service definition, and that basically you'll have say you'll have multiple if you have multiple pods and you want. Or again, even if you have one pod and you want to access that with a particular IP address, of course, that kind of IO magically goes out and takes care of that on the Google Compute Engine side. You can also include a line in your definition, public IP, and I think, do I open that? I'll show where it is. Yeah, this public IP, you can just stick a static IP in there, and then the service will it will be listening on that IP, and so it's a matter of just for the OpenStack case, you could probably use the load balancer element in OpenStack, or you could do some HA proxy thing or this thing that I mentioned here, this Kiwi. One of my coworkers at Red Hat wrote this little service that it looks, when you reference the, I'm forgetting now exactly how he does it in the definition file, but you add in this reference, and it will add the IP address to the it just kind of takes care of this to the hosts, so that it will be there to listen for when you tell your users come clone from the repo here or wherever, visit this web page. But that's the thing that is, you can see the date on the blog there is February 10th. That he just put up that post, and I haven't actually played with it yet, but that looks like a cool option for this. And, when you're testing it, you kind of want to go to sort of not production, but you want to start kind of doing something with the app and playing with it or giving it to other people to look at. That's something that is obviously important. Let's see. All right, so let me take a look here, see where we're at now. This one, this F21 Atomic, is my master. So there's a master, and there are minions, and the master keeps track of what the minions it should be doing, and the minions go out and do the bidding of the master, or they're also called kubelets. And you can say kube control get. This is get minions, and those are my two minions that I have. This is just VMs running on my notebook here, or get pods, and hopefully one of them is not going to say failed. All right, good. Yeah, again, I was, as I was setting up this demo, I was having some issues, and I thought they might rear their heads, but it looks decent.
Do you need to specify the Kubernetes which host to run on, or doesn't it distribute them out by itself?
It takes care of it itself, and actually, this is another thing I mentioned before that, that's something that they're working on. It doesn't even, unless I'm mistaken, I believe the current status is it's not even being very intelligent about how it does the scheduling. It has, you configure your cluster with these are the minions that you have, and it just goes out and assigns them. And what's happening on the minion side is, it's pretty straightforward Docker stuff. You can, so Redis is on this one, right? And this is the Redis service here. This one at the bottom with the 6379, and then that means that Postgres and Gitlab must be on the other one, and there they are. And then you can do things like just kind of bait your normal Docker debugging type of stuff, where I'm looking at the logs here of this particular of the GitLab container. Let's see, and in fact, it should be up by now. Yeah, you can pass. You can get logs from minions, and I'm forgetting the syntax right now, but there's a kube control command where you're just sort of passing through some Docker commands to your minions and to Docker there. So getting the logs is one that definitely comes in handy, especially as you're putting it together, and things like I mentioned, if it's out of order, and now my this complicated bash script that I got some little complicated bash script that I was talking about. Let's see, is it on 12? Oh. And that's GitLab's running there. But at some point in it, something has gone wrong because the environment variable is missing, and it's like some sort of a sed command that is swapping out something in a text file. And so I definitely underwent a lot of hair pulling, going through that. This will stop vibrating. But yeah, you can. And I'm sorry, don't remember the the syntax right now, but from the master, you definitely can do that. And then you can also access the master, like when I was doing these ones here. This is from, I'm just talking to the master, just passing the server location there and interacting with the master. Let's see, what else? But yeah, this is GitLab is running, and now see, I've got this on this 10,080 port, and I had to look up the address of the pod that it was running on, and this is where the external load balancer bit or the public IP bit and the load balancing and figuring that out, that's where that comes into play, because obviously you don't want to do that. And then also, like for GitLab has SSH, it's running SSH inside of it, and when you push to GitLab, you or feel familiar. And GitLab is basically just like a work-alike of GitHub that you can is open source and you can run internally. So you want your users, when they're talking to GitLab, they need to talk. They're communicating over SSH, and then you either are going to have to give the users a non-standard port to SSH to, or you're going to have to SSH to your minion over a non-standard port. And this is the sort of thing that services allow you to do. Like I say, okay, well, instead of worrying about that, I've got my GitLab SSH service, and so that will be running. And so traffic sent to that static IP here. It's not. I don't actually have it running here. Will go to the appropriate minion, and the services are keeping track of who that is. Yeah. So this, the next steps for me in this, the guestbook application it's using only Redis as the data store. So that's all replication is sort of dealt with in that, but so many apps obviously are using Postgres or MySQL, and it's not as they're definitely solutions, but it's not as simple, I guess, or designed necessarily from the ground up in that way. So I've got to figure out before I actually, because I am still running this app in that Fedora VM at this point, right? Because personally, just the time that I've been using Kubernetes, again, it's like 6 months old or something, but it's been changing so much, and there's so many things that still are being figured out, that even in my limited use case, I'm kind of close to saying, okay, I'm going to cut over, but, I really don't want to be fielding calls from everybody about how they can't get to, the logos that we store and whatnot in our repo. So persistence is another thing. This is sort of related back to the Postgres. GitLab is pretty simple to back everything up, and then just on a brand new GitLab install, just pour it back in. And so then do I want to care about persistence? Is that just going to make it harder? You can do it in Kubernetes. You just in your pod definition file, sort of similar ideas to how Docker does it. These are the volumes. And then you have to decide, okay, am I giving it a volume that's on this particular host, and now the data is there, and so now I have to worry about moving that data around. There's another, some of my coworkers at Red Hat have been playing with using Gluster for these host-mounted volumes. So you have, it's like the data is stuck there, but it's not really, because it's behind the scenes in a distributed storage. The GitLab container itself, it's got cron in there, it's got SSH in there, it's got Nginx in there, it's got the Ruby in there. Docker doesn't have to be one process per container, but that's kind of the design pattern that is most favored, and so that GitLab container can totally be further exploded, and that's something that I will probably be exploring. Even if it's not something that's strictly necessary for my use, just as continuing to understand the technology better. And then like we've been talking about, the static IP business, I want a good, solid solution for that. Because again, Well, most of these are problems that I have in my simple use case, and it's not like, that little VM is just, running like a champ. So and it is itself running on over, a virtualization platform that does have live migration and stuff and snapshotting and all these things. So it's more of exploring the technology than driven by I can't get by without this. But certainly in a larger installation, these issues would be a lot more important. I think I'm doing decent on time. More info. This is all this stuff is kind of the stuff that we were working on in Project Atomic. It is sort of a meta project in some ways. It is a method of putting together a host. It's also Kubernetes is the orchestration method that we include in it, and Docker is the container host, and it's just sort of a place. This is a place where integration of those stuff come together. Get the Kubernetes repo on GitHub if you're interested in it. It's well worth checking out. We've got a ton of info, ton of examples and how-tos. We got this Stack Overflow type ask site, and I think any questions?
Not a question so much as thanks for the shout out. I actually work on the Kubernetes team.
Okay.
Thank you for everything you're saying. It's a great talk.
Oh, cool. All right, I'll put one on my laptop. I recently got a new laptop, and it's almost sticker free at this point. Anybody?
Two questions. You've been pushing this code back up to some GitHub repository somewhere, or
Well, which?
pod file?
Yeah, there's a blog post that I wrote about this that sort of made this an easier talk to put together. And this is on the Atomic site, and this is, basically similar to what I've been talking about. This is in January, and I have, my learnings have continued a little bit since then. But referenced in here is the GitLab repo, GitHub repo, where all that stuff is there. And totally check it out and file bugs and or fork it but that's and another thing too is that especially for people who know more about this than me, I'm definitely, I think I even call it out at the end. I mean, any suggestions about how to do the little parts of it better, or things that other people have been learning about in their explorations of it, I'd totally appreciate it, because it's a fast-moving thing. But I definitely think it's cool, officially cool, but I do also think it is cool, genuinely cool, and it's been fun to work with.
Have you explored running with the Dockerized Gitlab under Mesos? Have you evaluated Kubernetes to Mesos? Why?
Not at all. But that is a topic that is on my radar and I'm interested in. But I mean, I'm at the point I mentioned that as far as how is Kubernetes exactly going to schedule resources, I believe I have heard some talk about, there could be some role for, Mesos and that.
Mesos already does that already.
With Kubernetes?
Yeah.
Mm-hmm. Yeah, I would be interested to learn more about it for sure. Mesos is something that we're interested in at Red Hat, and there's been activity around that as well. And it's not as ingrained in the Atomic stuff at this point, but it's something that a lot of my colleagues are working on, and I want to learn more about too.
Just to that point, there is some movement to run essentially a Kubernetes front end on top of Mesos.
Okay.
Which uses the Mesos brokering system and then runs a Kubeflow sort of bottom. So you get the Kubernetes user experience, and you get the advantage of Mesos as sort of more mature scheduling and brokering.
Okay, cool. Is that documented at all in the Kubernetes repo?
There's a couple of blog posts from the Mesos folks about it. I think it's actually pretty well officially supported.
Okay. Yeah, that's something. Thanks. I'm going to check that out.
I was wondering if Project Atomic has something basic or container property cluster by itself, and Kubernetes adds more functionality on top of that, or do you pretty much have to
Well, Kubernetes is, there's only, part of Project Atomic is that it is a sort of a streamlined host, and it updates atomically. So there's certain things that are in it and aren't in it. I mean, Kubernetes is in it. Now, there's lots of interesting things you can do. You can run a lot of things in a container on Kubernetes, actually, performing system tasks. But this is right now, this is the way that, this is kind of where we've been placing our attention for orchestration in Atomic. But, in fact, Joe Brockmeyer is going to speak in a little bit. You can pretty easily make a modified Atomic host, and you could put anything in there. So, but as far as like where we've been placing our attention, it's been on, okay, this is our orchestration bit for now, but it's, again, flowing like, it was mentioned earlier today, there's a project called GearD that was our orchestration thing that just started, and then Google came out with Kubernetes, and we said, oh, hey, this looks like a good fit, and so let's, work on this. So it's definitely in flux.
Red Hat has something like 15 people full-time working with Kubernetes. Like, the tie-ins between Atomic and Kubernetes are not quite as obvious yet, but like, you've heard about OpenShift, the new Red Hat PaaS platform is built entirely on top of Kubernetes. Red Hat's awesome, and we are completely overwhelmed by the amount of work that you guys are putting into us.
Sweet.
Getting overwhelmed in like the I can't keep up with the code review.
Okay, all right. Well, I think the Red Hatters can help with that too.
How are you storing all this, like the code, like are you mounting the filers like in the backend or like in the dedicated nodes, or using some DFS in the backend?
I'm not sure I understand.
Do you mount like the filers to store all your source code, like in the GitLab, or do you use DFS like Ceph, Gluster, whatever?
Well, that's part of what, so, right now it is, I have it's like a virtual disk attached to my VM is where now the code is. But that's part of the question, how big, like right now our repositories are only so big, and so there's only so much data, but part of what I'm thinking with, persisting, I'm thinking, and also this is really a test app that we just really started to depend on, and every chance I get I'm telling people, oh hey, I'd love for someone to take this off my hands. So that's a good question. I'm not using a filer right now, but that is one thing that I think I'm going to at least try out is, some of my colleagues have been doing testing around using Gluster for those volumes.
Speaking about that, is Red Hat high on Gluster or Ceph? Because I thought that you are promoting both of them.
Yep.
So have you narrowed down like whether you DFS, like Gluster is going to be your DFS or like Ceph?
At this point, it's just Red Hat is into them both. I personally know more about Gluster because we bought Ceph more recently, and like I am paying attention to like 7 projects, and so I'm like, I can't even think about Ceph, but then now Ceph is part of the family, and so I just now I feel bad about not learning more about it yet, but but I mean officially, there's lots of people on both of them, and they're both. I kind of think it is just these two sort of teams attacking this. The bigger thing is the software-defined storage and the scale-out storage, and so it's kind of a big shift towards that, and so there's just sort of like we're battling it on different fronts, sort of. It's sort of kind of how I'm thinking about it. As someone who doesn't speak officially, on anything. That's kind of how I understand it.
I'm dying for somebody to do a demo of Kubernetes plus Ceph with Kubernetes plus Gluster or Kubernetes plus Blocker or whatever. I'm encouraging anybody who listens to me or interested in the space, like do a demo and we'll give you a platform.
Yeah, well, it's I think it's Steve Watt just did one on Kubernetes and Gluster. No, the Twitter result came up first. This may or may not be this is it. This is a blog post where he's talking about, one thing we had to do, I don't think he's using this with Atomic because Atomic doesn't include Gluster as part of the image, but again, you can add it. But he has been testing just this thing, putting the images, or putting the volumes on Gluster. And so this emergingafrican.com is his website. But yeah, and this is something that I've been looking forward to trying out too. This is again just earlier this month. All right, I guess we're right on time. I'm not sure who the next person is. Do people have more questions? I'm not being pulled off the stage yet. Well, thank you. I appreciate your attention.